Question 2. The discrete random variable x has this probability distribution. So x can take these particular values, -2, -1, 1, 2 and 3, with these probabilities, and a and b are constants. So part A asks us to write down an equation for a and b. So we think about what we know that involves a and b, and what we know is that a plus b plus b plus 1/5 has to make 1, as in 2a plus 2b plus 1/5 has to equal 1. Now that's all you have to do to get 1 mark, but personally I'd be tempted to go a bit further than this to really check what it's telling me. If I subtract 1/5 from both sides, I get the fact that 2a plus 2b must equal 4/5, which of course it could. These two plus these two must make 4/5, so that when I add on 1/5 I get to 1 whole. And if I divide through by 2, that's telling me that a plus b must equal 2/5, and of course it must. This a plus b would make 2/5, this a plus b would make 2/5, so that's 4/5 altogether. Then add on the 1/5, gets us to 1 whole. And that's all we can do with this. We can't narrow down now what a and b are, so we stop. Part B says calculate the expected value of x. So for that, we think about the fact that -2 happens with a probability of b, and we sum with that -1 having a probability of a, and we sum onto that +1 having a probability of a, +2 having a probability of b, and 3 having a probability of 1/5. Now what do I notice? -2b and +2b cancel out, and -1a and +1a cancel out, giving me 3 lots of 1/5, which is 3/5, or 0.6. Now we're told some more information. We're told that the expected value of x squared is 3.5. And now we use that to create a second equation in a and b. So now, for the expected value of x squared, we think about, well, okay, so if this x had been squared, it would have been a 4. And what was the probability that you would generate a -2, which would then square to 4? It was b. So we weight 4 with the probability b. And similarly, -1 squared is 1. That gets weighted with the probability a. And 1 squared is 1. That gets weighted with the probability of a. And 2 squared is 4. That gets weighted with the probability b. And 3 squared is 9. And that gets weighted with the probability 1/5. And we're told in the question that that is equal to 3.5. So now I can put 3.5 for my expected value of x squared, and I can collect this together a bit. So now I've got 8b and 2a and 9/5. Now 9/5 is 1 whole and 4/5, or 1.8. So I could put in a decimal here to match with this decimal. This did only ask me to find a second equation in a and b, so 3.5 equaling to that will be absolutely fine. So let's see what it's going to ask for next. Hence, find the value of a and the value of b. So now we're really just in pure algebra land. We're trying to solve the pair of simultaneous equations that we have. One of them is up here. Let's label where I'm getting it from. Equation 1 is that a plus b equals 0.4. And this will give me equation 2, which is that 3.5 equals 8b plus 2a plus 1.8. I'm going to do some simplifying with this before I try to use it, because that one I had already simplified. So if I subtract 1.8 from both sides, I get 1.7 equals 8b plus 2a. Then I could divide through by 2 and I get 0.85 equals 4b plus a. And now these are looking quite similar. So I'm going to call this my edited 2 equation. And because I have a in both, I'm going to do 2 dash minus equation 1. So if I take this side, subtract this side, 4b plus a, take away the a, so that's gone, and 4b take away the b is 3b. And for the other side of the equation, I can do 0.85 take away 0.4, making 0.45, and dividing through by 3, b is 0.15. And if I substitute into equation 1, because a plus b is 0.4, a plus 0.15 is 0.4, and therefore a must be 0.25. So that's b there, and that's a there. So next up, part D asks us to find the variance of x. So to work out the variance of x, we need the expected value of x squared and to subtract the expected value of x all squared. And we know both those things because the expected value of x squared was told to us in part C, 3.5. And the expected value of x we worked out in part B was 0.6, which needs to be squared. And if I put that in the calculator now, 3.5 take away 0.6 squared, I get 3.14. Now, we're told that a random variable y is defined by doing 5 take away 3 lots of x, and we have to find the probability that y is greater than 0. Well, the probability that y is greater than 0, because y is equal to 5 minus 3x, we're really asking when is 5 minus 3x greater than 0. And if I solve that inequality, I can add 3x to both sides and divide by 3. I'm really asking when is x less than 5/3, or alternatively, when is x less than 1 2/3. So let's have a look in the table, because this is a discrete random variable that can only take particular values. So where do I find cases where x is lower than 1 2/3? It would be these options. So if I want to work out the probability that y it comes out greater than 0, then I need to think about these probabilities, b, a and a, because these will generate these x values, and when I do 5 take away 3 lots of these, I will make sure that I get a y that's greater than 0. So that means to work this out I need b plus 2a, and b is 0.15 and a is 0.25, so that's 0.15 plus 0.5, and that makes 0.65. Now for part F, I need to find the expected value of y and the variance of y. So I'm going to squeeze those onto the side of my page here. Part F, expected value of y. So let me record here the relationship. Y is equal to 5 take away 3 x. Good. Okay, so we can think of this as the x values. We could think of it the other way around. The x values have been multiplied by -3, and then we've added on 5. Now, both of those things are going to change the mean. So what I want to do to find the expected value of y is I want to take the expected value of x, multiply it by -3, and then add 5. So this is going to be -3 times, now the expected value of x is there, 0.6 plus 5. So that will give me -1.8 plus 5. So altogether that would give me 3.2. And then we have to find the variance of y. Now this is a bit different because when I multiply the data by -3 and it changes the way it's spread out, that will affect the variance. But when I add 5, that will just shift all my numbers up 5, and that won't change the spread. So I need to remember that. And not only this, because a variance calculation involves squaring, I find that this -3, the effect of it, needs to be included in a squared form. And -3 squared is 9. So I'm going to need 9 lots of the variance of x, and that's going to be 9 multiplied by 3.14. And that gives me 28.26. So let's underline those: expected y and variance of y.